Okay, we're on 4.1, continuous compound interest formula. All right. So we learned special kind of interest, I guess, where you just add on part of it every so often, some number of times per year, until you get to the end. That's where the over n part, that's part of the interest rate, and then you do it that same number of times for however long. However, consider this thing here. So let's just start at 1 plus, pretend the interest rate is 100%, which would be just 1 in this case, divided by n to the n here. And forget about the time. Let's assume the time is also just 1. So if it was 1, I wouldn't have to write n times 1 here. So if I compound this more and more and more, remember the number from the last section, subsection, it got larger and larger and larger, but it actually started leveling out at a specific number. So when I increase this n value, so n gets large, and I mean positive, so in our end behavior notation, that would be as n goes to infinity. What happens to this thing? I'm just going to tell you. It goes to approximately this number 2.72-ish, and we're going to call it the number e. So e is approximately that value. This is called, it's called notation. So the number e. So it's like pi. It's a special letter that we use for a number. Pi is one of those non-repeating decimal numbers. You might say it's irrational. E is same deal. This is approximately 2.72, and this number is called Euler's number. So it looks like Euler, and that's what you want to say probably when you read it. And I said it that way for many, many years. But it's Euler, like oil, and then That's how you say it. This guy came up with this number, hence the E. So using this idea, I want to not just compound it once a year, compound some interest once a year or twice a year or 3 times or 200 million times even per year. I just want to always be compounding it. And that's what this idea is as n goes to infinity. You never stop compounding, I guess. And it turns out you level out at a specific value here. So we're going to use it. For interest, that is compounded continuously. So for the other types of problems, you're going to hear compounded some number of times per year. If you see this word in an exponential problem, continuously, it is a safe bet that we're talking about the number e here. So for interest that's compounded continuously, the amount after t years. So this is the amount, just like the the other compoundedness. It's the amount you have after you add on the interest after 2 years. So this is A for amount, and is the principal times that special number E. Remember, this is a number now. I'm never going to use E as a variable anymore because we'll reserve this picture for approximately 2.71. But or 2.72, sorry. But it's P times E to the RT. So this E part, actually the E to the R part, I guess, takes care of 1 plus R over N to the N. The N is gone to infinity, and R needs to be left over somehow, so it is, I guess. And then don't forget there was a T up there in the exponent, so it's still here. That's not really the reason exactly, but it's just maybe a way to remember it. So you might have heard the phrase PERT for these types of questions. This is what we're going to use for compounded continuously. And this is where R is the annual rate. So the rate is always per year. And so R is the annual rate. But since you're compounding it more and more, the actual rate ends up changing. But remember, if you see the word annual, we're talking about R. P is the principal. And T was in years over here. Oops. There, let's leave that alone. So let's do an example. 9,000 is invested at 7.5% annual interest rate. Compounding continuously. Find the amount after 10 years. Okay, so it's one of those interest banking problems. You're using either the 1 plus R over N to the NT formula, or for the amount, or you're using PE to the RT. And how do I know I want to use E? Because I see the word continuously, especially compounded continuously. So let's do it like we did before. We have A, we have P. E is a fixed number in this case, so I don't have to figure out what E is. It's just already a number. But we have R and T. So 9,000 is invested. That's the beginning amount, so that's the principal. 7.5% annual interest rate. R is the annual interest rate. Not 7.5 because math people don't like percents. They like the 0 to 1 version. So 0.075. And then after 10 years, well, T is years, so T would be 10. And the last one left over, hopefully that's the question. Find the amount. So yeah, we'll leave A for the question. So A equals PE to the RT, and that's 9,000 times e raised to the 0.075 times 10 power. And this is all in the exponent for e, remember. So in this one, you definitely would need a calculator to get a decimal approximation. And I did that already. You get 19,053-ish. Okay, that's it for this subsection.